All right, so for warm-up number 11, we got simplify numbers 1 and 2. And for number 3, to solve, graph, and write solution set. All right, number 1, what'd you get, Joel? Okay, let's see, help him out, Diego, what'd you get? An answer for number 1. 14x squared plus 8. Hands if you got that in any order. Okay, close. Let me go over this just to make sure. We got 7m, then we got minus 2m, and then minus 5m. So let's combine like terms first. Negative 5 and negative 2, that's negative 7. Plus 7, that is 0. So these cancel, okay? Next, we got negative 9x squared and positive 5x squared. That gives us negative 4x squared. And then 10 minus 2 is 8. Hands if you got that. Okay, not bad, not bad. Number 2. Check with your neighbor before I call on someone. Number 2, what they got for number 2 in any order. Isabella Gradillas, what you get? Negative what? 3x plus 15. Oh, okay, so you gave me this and that, so you're right here. So this is negative 2x to the second. That is correct. And then plus 6x, okay? Hands if you have that in any order so far, guys. Okay? So we need one more step from here. Double check with your neighbor, see what they got. That last step, Jose, go. What'd you get? Plus 15 minus 2x squared in any order. Hands if you got that. All right, not bad. And last but not least, solve, graph, and write solution set. All right. So tell your neighbor what you did first for this one, and then second before the graphing, and then I'll call on someone to help me out. Good conversations. Valente, go. Oh, what did your neighbor say? All right, so when I ask you guys to share, guys, it's because I'm giving you an opportunity to know exactly what I'm going to ask. So, Dylan, help us out. Add 5 to all sides. Add 5, add 5. We got negative 20 less than 4x, less than or equal to 12. Continue, Ayana. 9, sorry. Divide by 4, divide by 4, divide by 4. We got negative 5 less than x, less than or equal to 3. Hands if you got that. All right. How about the graphing? Share with your neighbor what you did for the graphing, please. What you do for the graphing. Who? Oh, JP. All right. Let's see. For the graphing, Anaya, pass it to someone. All right, Alessandra, for this part, where do I start? The dividing point 3, okay. Is it a solid or open point? Solid, okay. And then? Different number for x. I'm going to try 0. Is 0 less than or equal to 3? Yes. There it is. Thank you. I'm going to do the second part for the sake of time. Negative 5 is our dividing point. Does it have an equal sign? No, it's an open. I'm going to substitute 0 in here again. Is negative 5 less than 0? Yes. So, what kind of inequality is this, guys? And, therefore, solution set of x such that negative 5 less than x less than or equal to 3. Hands if you got that by yourself. All right. Copy the agenda for today, please. Today we're done with warm-up number 11. Today we're moving on. We're getting into classification of polynomials. It's a new module, new term. But you already covered this in Algebra 1, and I'm going to slowly but surely get us to where we need to be. And today we start with the simple naming of polynomials, also known as classifying polynomials. Tonight's home plate sheet number, classifying polynomials, only 12 problems for the play sheet today. All right. And for today, there is no Nearpod code since I included the play sheet in Canvas, so you can go there. So once again, no Nearpod code. However, there was a home plate last weekend, right? What was the home plate? The play sheet. And what else? The signed progress, right? So, check this out. I'm not even going to collect the play sheet, but I do want your signed progress. So go to Canvas right now. Go to the third module. I included a new module titled Polynomials. Go in there, submit your home plate. You should have your screenshot on your cell phone. Submit that. You're like, Mr. Q, I did everything except the signature. I'm like, what? Come on, guys. And this is the home plate for tonight. You should find it in Canvas right there when you see the module. And get a Cornell note ready, please. You do need a fair model. I'll give you some time for that. Copy and go. So yes, guys, today, like I said, it's going to go a little fast. I'm going to go over a lot of terminology just to refresh your noodle to make sure everybody understands what we're talking about. Because we're going to dive into polynomials this whole week and probably next week. And from there, start building up from there, okay? And yes, I don't know if you noticed when you were in Algebra 1, when you got to this section, some of you struggled a little bit. But guess what? Ever since they introduced polynomials to you, they're here to stay, even in your higher mathematics, so they're here. One day you're going to be walking over there by Donut, you're going over to get your iced tea, and then you hear in the corner, you turn, polynomials, let's go. They're never going to leave. All right, y'all ready? All right, here we go. Our objective for today, I can classify polynomials. I can classify polynomials. Tell your neighbor the concept for today. What is the concept for today? Yeah, polynomials. We know the concept. What are we going to do? Classify. What does that mean, Mr. Q? In parentheses, just write name. Write the word name. That's what classification means. We're going to give it a name. We're going to be giving polynomials a name. So let's start with the definition for polynomials. What are polynomials? Definition. They are monomials or some or difference of monomials. They are monomials or a sum or difference of monomials. Polynomials are what? Monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. So you neighbor the definition of polynomials? I did some Jedi master stuff right there. Pretty good, right? All right. Now some of you are like, that's good and dandy, Mr. Q, but I have no idea what monomials are. Right? Some of you forgot. Okay, let's start from scratch. Y'all ready? Look up to the screen. Writing utensils down. All right, here we go. Okay, I'll wait. Ready? All right, here it goes. Let me elaborate on monomials. Monomials come from the root word mono. Mono means one. Even in Mexico, when I grew up in Mexico, whenever we were meaning someone, like one person, oh, that mono. We would say mono, meaning one person. So check this out. An expression of one term can look like this. Look up. 2. Do you agree it's an expression? Yes. One term? Yes. Let me show you another one. An expression? Yes. One term? Yes. These are monomials. They're part of the polynomials. But the definition says sum or difference. That means that you can add or subtract more to a monomial. Let me show you another one. This together is a polynomial. This is not a monomial, but it's the sum or difference of monomials. So watch. Negative 3x to the 4th, they're adding what? 2. So that means a monomial plus another monomial. This is a what? Polynomial. Let me show you one more. We got x squared, monomial, subtract 3x, monomial, plus 2, another monomial, and all this together is a what? Polynomial. Copy that, please. I'll copy all of these. Yeah, they're all part of the polynomials. So, one more thing before I show you non-examples. Look up to the screen. You all right over there, Frida? All right. Here it goes. The word polynomial is a compound word. You guys know what a compound word is, right? So if I was to give you the name for poly, the original root word means, what is it? Many. Many or multiple. Thank you. Yeah, many. And the word nomial means part or parts. So within itself, you have the definition, right? A polynomial has what? Many parts. That is correct. And we see that right here, yes? All right, so let me show you non-examples. Look up. Don't copy this. Now tell your neighbor why obviously these are not polynomials. Why are those not, bless you, polynomials? All right. Juan, you got it? Why are these not polynomials? They have an equal sign, so these are equations. So what does that make these? Tell your neighbor, what are these? Aside from polynomials, what does that make these? If these are equations, they're non-examples, what are these? Yeah, so our first hashtag would be what? Hashtag expressions, yes. And copy the non-examples. Who can give me another hashtag? What makes a polynomial polynomial? Hashtag what? Not equal, okay. And one more, I'm going to give you one more. Many terms. Many terms. Many parts. Yeah, we can add hashtag BAM. Let's go. All right. So hopefully this is clarifying. Notice that we haven't done anything yet. I'm just clarifying what a polynomial is. But there's more terminology that I need to go through. Okay, here it goes. I'm sorry. No, you don't need another fair amount for this one. Just sit back, relax, and I'm just going to go through it really quick. Here it goes. Next terminology that I'm going to be using. Here it goes. When I talk about terms, it means the parts of an expression. How do we know when one term starts, one ends? It's whenever they add or subtract something, that's when it ends, and that's when another one begins. And I'll show you that in a little bit. There's also something that I'm going to be using called like terms. That's when you look at the parts of the expression. That's when you have a term with the exact same variable or variables with the exact same exponents. And some of you are saying, well, Mr. Good, what if it doesn't have a variable? Then you're just going to look for numbers that are by themselves. Those are like terms. Whenever they're numbers by themselves, they're just constants. So here goes an example. Look up. If I give you the expression 4x minus 3x plus 2, which ones are my like terms? Talk it over your neighbor. Which ones are my like terms? Like terms. Yeah. The like terms are 4x and 3x, which means the 2 that does not have a variable is known as a constant, okay? Next, whenever I'm talking about coefficients is talking about the number that multiplies the variable. So look up to the expression. Can you locate the variables? Yes? All right, tell your neighbor the coefficients, which means the number multiplying the variable. Which are my coefficients? All right, Frida, coefficients? Coefficients? I'm sorry? I'm sorry? No, the coefficients. What are the coefficients? Okay. Help her out, Jose. Close. The number itself multiplying the x is 4 and 3. From now on, guys, whenever you're looking at a coefficient, I want you, if it has a negative in front of it, now it's going to be what? -3 from this point forward. Okay? Next, whenever I give you an expression and there is no number written for the coefficient like this, x squared plus x, automatically assume that it has a 1, an invisible 1, okay? All right, is all this coming back? Yes, I know I'm going a little bit quick through this because I want to get to the lesson, okay? Next, 2 more things. Whenever I give you a variable, look up. If it doesn't have an exponent, we know that it's an invisible 1. Cannot be 0 because then it wouldn't exist. So it has to be 1. And last but not least, look up please, degree. When I ask you for the degree of a polynomial, you're going to take the sum of the exponents of the variables of the term, and then you're going to go with the highest one, the highest degree. Look up, please. Let's say I gave you 3 plus 4xy squared plus 5y. All right. So it says here a degree is the sum of the exponents on the variables. Question, does this one have a variable? So this is 0 degree. Look at this one. Does this one have variables? Yes, so we're going to add the exponents. So what is 1 plus 2? 3. Okay. Does this one have a variable? Yes, so this is 1, so this is degree of 1. So we're going to go with the what? Highest. So the degree of this polynomial is 3. Is it coming back for some of you? Yes? Let me give you another one just to make sure we got it. Let's do 7 plus 2ab plus 4a to the 5th plus 9b. All right, look at it. So you know the degree of that polynomial. What's the degree of that polynomial? All right, I think Briseda's got this. What's the degree of this polynomial? 5th degree or 5. Hands, have you got that? Yeah. So we got this, yes? All right. So with that said, Now that we have all the terminology out of the way, copy this one, example 1. Example 1. Just a polynomial. 6x squared minus 5x plus 4 plus x squared, and then copy the questions. And we're going to go through this one together. How many terms are there in the expression? Identify the like terms, identify the constant, and identify all coefficients. I'll give you a head start, and then we'll go through this together. Copy and go. Before we go over together really quick, check with your neighbor, see if they answer some of those questions, at least a couple of them, and then we'll go through this together. All right, here we go. Y'all ready? I'm going to start with black, and I'm going to start reading this expression from left to right, but I'm going to underline each term, and I'm going to stop wherever there is addition or subtraction, so like that I know how many terms there are. Here we go. I start and I stop because there's a subtraction there. That's one term. I start and I stop. There's an addition. I start and I stop. There's another addition. I start and I stop because there's nothing else. So how many parts or how many terms? 4. Hands if you got that. Okay, not bad. Next, we got like terms. Like terms. All right. We said that the parts of the expression that have the exact same variable and exact same exponent. So you should have written, let's see, 6x squared and x squared. Hands if you got that. All right, not bad. Next, constant. Constant. It's the number that's by itself. Doesn't have any variable or anything, so the correct answer is 4. Okay. And last but not least, all the coefficients. All the coefficients. Let's see if you get this one correct, if you didn't forget. First, locate all the variables. Here's a variable. Here's a variable, and here's a variable. What numbers are multiplying those variables? 6, comma, -5, comma, and 1, comma. All right, from 1 to 5, how comfortable do you feel with these? 5, 5, 5, 4, okay. Let's do another one. Example 2. Example 2. Copy this. Give me a second. Oh, let it go. Example 2. Here we go. -1a squared plus 5ab cubed plus 7a squared plus 2 plus 3ab squared. See how you do with that one. I gave you a little challenge, but let's see how you do. Answer those questions using that expression, please. You don't have to copy the question anymore. If you want to just do a little different color next to the questions that you already wrote before, and just answer it there. I'll give you some time. Copy and... All right, good conversations. How many terms are there in the expression? Jalen. Jalen says 5. Let's double check. 1, 2, 3, 4, 5. Hands if you got 5. Okay. All right. Identify like terms. How about the like terms? Alyssa, what'd you get? -1a squared and 7a squared. Hands if you got that? That is correct. Now, she said this one and this one. All right. Tell your neighbor why not this one and this one also. Talk to your neighbor, let them know why not that one. Yeah, even though they have the exact same variables, do they have the exact same exponents? No, that's why we don't go with those, okay? What is our constant? Constant. We should have gotten what? 2. And last but not least, all coefficients. Tell your neighbor what they got for their coefficients. See if they have the same thing as you. All right, Christopher, what'd you get? -1, 5, 7, and 3. Hands if you got that. All right, we got this, yes? Notice we haven't even done anything about the lesson. The lesson was to name polynomials, but I just wanted to clarify all the terms before we jump into the polynomials module. All right, so now that we got this, check this out. Write your utensils down, look up to the screen. So we're going to start with classification of polynomials. I'm going to give you a process as to what to do, like, you know, the steps. However, I want to show you the tool that I put together. Mr. Q, I made this one up. You're like, what? Yeah. And by the way, like a lot of the things that we do here in class, I put together just so that's the way I look at it, so hopefully it helps you guys look at things like this. So check this out. We said we're going to classify polynomials, which means give it a name. Well, polynomials have 2 names. They have a first name and they have a last name, just like us. The first name, I put it in red because it has to be according to the degree of the polynomial, and the last name is according to the number of terms. And look at the tool that I put together for you guys. Look at this. Don't copy it. Look up. The number of degree, it has a name for it, and the number of terms, it has a name for it. And whenever they intersect, those 2 things give you the name of a polynomial. We're going to be using this tool. You can copy it later by going to YouTube, or I'm going to have you take a screenshot in a little bit. But look, this is how it works. Look up, please. Don't copy this, just pay attention. Let's say I gave you the polynomial, look up, 2x cubed minus 1. And I ask you to classify or give it the name. So you need, first of all, a degree. How do we do that? Well, we start by term. What's the degree of this term? 3. What's the degree of this term? 0. What's the highest degree? 3. So that means its first name is a what? Cubic. Okay, we got that. How many parts does this expression have? 1, 2. So according to these names, it's a what? So the name of this polynomial is a cubic binomial. Let's go. What's that? Yeah, so question was, what about 6, Mr. Q? Well, what if I gave you something like this? Watch. Let's say I gave 9y to the 6th degree, and that's it. So watch. First, let's find out the degree. What's the degree of this term? 6. Okay, so we know that it's 6 degree. How many terms? 1. So this is a what? Monomial. So the name of this one is 6 degree monomial. That's how you name them. Okay? All right. So, with that said, now that we know how to use the tool, let me zoom into the steps, copy these steps. This is the steps that you're going to use for your home play and for what we're going to do for today's sesh. There it is. I'll give you some time. And it reads, step number 1, identify the degree of each term of the polynomial. Step 2, arrange the terms of the expression from greatest to least degree. This is what we call standard form. And identify the leading coefficient. And number 3, classify the expression according to the greatest power number of terms. Example Q says, classify the polynomial 6x minus 7x to the 5th plus 4x squared plus 9. All right? Okay. Let me write this out first, go through the process, then I'll have you copy right after, okay? Writing utensils down, look up to the screen. Here we go. All right. I'm going to start with black. Step 1, it says identify the degree of each term. Degree of this one is 1. Degree of this one is 5. Degree of this one is 2. And the degree of this one, no variable, is 0. Step 1, done. Step 2, look up please. Arrange the terms of the expression from greatest to least. That's what we call standard form. So what is the greatest degree here? 5, so I'm going to write the term negative 7x to the 5th. Check mark. Next one, 2. My term is 4x squared. Check. Next one, 1, positive 6x. Check. And last, 0 degree, which is 9, and I'm done. And this is called what? Standard form. Copy that, please. All right. So far we did step 1, identifying the degree of each term, yes. Step 2, arranging it from highest to least. But I'm still not done with step 2. Look up, please. It says, the last part of step 2, identify the leading coefficients. Well, first of all, do you know what the coefficients are of all the polynomials? Tell your neighbor all the coefficients really quick. Tell them what they are. Yeah, negative 7, 4, and 6. Okay, but the leading coefficient, pay attention to this part, is once we have it in standard form, it's the first one that appears from left to right. So what is my leading coefficient? Negative 7. This is my LC. Label that, please, in red. LC, leading coefficient. All right. So let's go to, that was step 2. We're done with step 2. Let's go to the last part. We're going to classify or give it a name. So what is the name according to the degree? What's the highest degree? 5. So this is a quintic. All right. How many parts does this polynomial have? 1, 2, 3, 4. So what is the name according to the terms? It's a polynomial. And we're done. That's exactly what you're going to do for home plate. From 1 to 5, how comfortable are you so far? Got some 5, 4s, 5, 5, 5, 4. Yeah, some of you will get there. Let's do another one. All right, here we go. Example. Let's see, this one was Q. Let's go with, yeah, let's go to this one. Example super Q. We got 16 minus 4x squared plus x to the 5th plus 9x cubed. I'll give you a head start, see if you can go through the process by yourself, and then I'll come right after to make sure we got it. Copy and go. Yeah, it's a polynomial. Yeah. Yeah, unless it's 3 or less, then you look for the other names. But anything after that is pretty much that. All right, get us started, please. Zoe, let's do step 1, degree for the first term. So we're going through the process. Identify the degree of each term. So degree for this one. Okay, Dylan, help her out. What's the degree of this term? 0, because it doesn't have a variable. Then you go to the next one. Degree for that one? 2, because that's the exponent on the variable. Degree for that one, everyone? 5, and then the degree for this one is 3. So step 1 is done, okay? Let's go to step 2. Arrange the terms from greatest to least degree. So the greatest one is 5, so that is x to the fifth, check. Next one, 9x to the third, check. The next one is negative 4x squared, check. And the last one is 16. What is the name of this one now that it's organized? Standard form. Standard form. All right, we're still not done. I need a leading coefficient. Tell your neighbor the leading coefficient. Leading coefficient. I saw Ivan lifting up his hand. Go, Ivan. I'm sorry? No, the leading coefficient. I'm sorry? X to the fifth power, but what number is multiplying the variable? 1, that is correct. That's my leading coefficient, yes. So I'm done with step 2. Let's go to the last step, classify it. First of all, what is the highest degree? 5, so this is a quintic. And also 4 terms, this is a polynomial. Okay. All right, a little bit better, yes? All right, let's do another one. Example, let's go to super duper cube. Example super duper cube. Copy this, please. Here he goes. Let's do 5ab squared c minus, give me a number, 23 Michael Jordan. All right. So arrange that, go through the steps, and give it a name, please. Leading coefficient. All right, so let's see the conversations. Step 1, identify the degree of each term. Julian, help me out. What's the degree of this term? 4. Degree of this term? 0. So step 1 is done. Step 2, arrange from greatest to least. What do you guys notice? It's already arranged, so check mark for that. So this is already in standard form. What's our leading coefficient? Fabian? 5. Label that, LC, that is correct. And last but not least, the name. Pass it to someone, Fabian. What's the name of this polynomial? Who? Lorena, what'd you get for the name of this polynomial? Oh. Close. Quadratic is 2 degrees. Christopher? Quartic binomial. Hands, have you got that? All right, do me a favor, take a picture of this table because you are going to need it for the home plate. Hold on, let me move it over. There it is. Yeah, if it has multiple variables, you add the exponents on the variables, yes? And once again, don't go selling this on eBay. I made this table myself, yes? Pretty good, right? That helps, right? Yes, Mr. Q. All right. From 1 to 5, how comfortable are you classifying polynomials? 5, 4, 5, yeah, we just need practice, yeah? All right, so we'll stop right there. Make sure you have that table, and those of you that haven't turned in your signature, your signed progress, make sure you get that signed tonight. Make sure you turn it in tomorrow as we walk in, and I'll stop the video at this point.